In this video, I want to talk about the electrical component called a resistor. Now, a lot of people look at resistors and they think of resistance, and resistance is sort of like friction in a circuit. And a lot of people are like, man, friction, it's bad. I got to get rid of friction. Well, not all friction is bad, and likewise, not all resistance is bad. The whole function of a resistor is to provide resistance in order to slow electrical current down. So keep that in mind. We want to slow electrical current down for many different reasons. The most important reason would be not to burn out or blow up another electrical device or electrical component inside our circuit. All right, because too much current can blow up an electrical device, it can blow up a battery, or it can burn down a house. So resistor's whole function is to control that electrical current to keep it from burning out something that's more important. Now, resistors come in all kinds of shapes and sizes. The most common shape that I've seen is a bean shape, all right, and it sort of looks like this. So please don't judge my drawing. Hey, get off of there. Nobody said click on there. All right, and it looks like a bean shape. All right, so all right, and it looks like this, and it has stripes on it. All right, so if you ever open up a circuit and you see this bean shaped object with all these stripes, this is a resistor, and it's very important to leave it alone. It needs to stay in there to control the electrical current that's flowing through your circuit. Okay, now you can erase this. I guess that doesn't want to go away. All right, so let's talk about what happens when we put resistors in circuits. Now, resistance, like I said, resistors provide resistance, and we measure resistance in ohms. So we're going to have this device right here, so where we have 5 ohms, and this down here we have 10 ohms. And if I put them in series, we can kind of get an idea of how these two resistors are going to combine. And so in a series circuit, and that's what this is, and if you want to review what a series circuit means, it means that the cathode of one device is connected to the anode of the other. Now remember, the cathode is where the electrical current flows out, so if the current flows down, this would be the cathode side, and this would be the anode side of the next resistor, and so this is a series circuit. Now, in a series circuit, the total resistance, or the combined resistance, in other words, if I were to take these two resistors and turn them into one resistor, is going to be equal to resistance of resistor 1 plus the resistance of resistor 2. Wow, that's kind of amazing. It's just growing back there, isn't it? All right, but I think I can keep going on. Let's see what happens. So if I have 3 resistors in a row, then it would be plus resistor 3. And then it's going to just be the sum of all of my resistors. All right, now that one's fairly easy. This is probably the easiest math that we're going to have, is combining resistors in series. Now, if I look over here at this type of circuit, well, this is going to be, once again, if my electrical current flows downward, well, it flows into the cathode. So these are, I'm sorry, it flows out of the cathode. It flows into the anode. So here we go. These are going to be anodes, and these are going to be cathodes. And so this is in parallel. So this is a parallel circuit. Parallel. All right. Now, when we get to a parallel circuit, we have to kind of think about some other math going on. And so we're going to have the total resistance again, so R total. All right, but now it's going to be a little bit trickier. It's actually going to be a 1 over relationship. So 1 over R1 plus 1 over R2 plus 1 over R3 plus ... So this would be R1. This right here would be R2, and then R3 and R4, all those would be in parallel. Now, this is a little bit more difficult. I recommend that you figure out how to do it on your calculator, and then you remember it. Okay? Sometimes it'll be easier just to do R1 divided by R1, and then equals, and then 1 divided by R2, and then equals, and then 1 divided by R3 and equals, and then add all of those up, and then 1 divided by that answer equals, and that will give you your total resistance. There's also a button on your calculator, or a couple buttons on your calculator. One of them looks like x to the minus 1, right? And the other one looks like a 1 over x. These are very important when doing this calculation because you can actually type in R1 and then hit the x to the minus 1 button, and then R2 and x to the minus 1 button, and then R3 to x to the minus 1 button equals, and then all of that to the x to the minus 1, and it gets you the total resistance. All right, so these buttons will help you out, and if you need help entering this into your calculator, just come let me know. Now, there are ways to check to see if you are combining resistors correctly, and each one of these is the same, or isn't the same, but each one of these has one of those check values or check equations or check statements that we can say. And if I look at the total resistance in series, I should always get R total is always going to be greater than R1, R2, or R dot dot dot, all of my resistors. So R total is always going to be greater than any one of my single resistors, okay? So if I have a total resistance, and let's say that this is 5 ohms and 10 ohms, well, my total resistance should be 15 ohms, which is greater than both 5 and 10. Now, in parallel circuits, the total resistance should be less than all of my resistors, R1, R2, R3, dot, 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 all of my resistors. R total should be less than all of my resistors. All right, and that's important also, because if I get an R total that is, let's say that this is 5 ohms and 10 ohms, if I get an R total at 7 ohms, well, then I know I've done something wrong. So your total resistance should be less in a parallel circuit than individual resistances. And you can kind of think of this intuitively as if I have a wire here, and I'm pumping electrons through it, okay, in that direction, well, I have a certain amount of current. Now, if I give these electrons an additional path to go, well, now I can start pumping a little bit more electrons down this side, right? And that more electrons increases the current, so more current, right? And that is going to give us less resistance, okay? So this is how we combine resistors in parallel and resistors in series, and so that's important to know. If you need any help on this, let me know, and I will come help you.